So let us look at the next proposition. This proposition states that if f is a bounded function defined on closed interval a b, uh, and if f is Riemann integrable on closed interval a b, then f is measurable and Riemann integral of Riemann integral over integral a to b f of x dx, that will be equal to integral a to b fx dx. So this is the Lebesgue integral. So if f is bounded and if f is Riemann integrable, f measurable ആയിരിക്കും, and the value of integral of f will be equal to the Riemann integral. Now, we know that every step function is a simple function. Now a given function f will be measurable if supreme over phi less than or equal to f integral a to b phi dx. So if that is equal to infirm over xi greater than or equal to f integral xi dx. So provided this condition holds, f is measurable, so we show that this is equal and hence f is measurable. Now every step function is a simple function, so therefore Riemann integral. The lower Riemann integral, that is step function. ഈ ലോവർ റീമാൻ ഇൻ്റഗ്രലിൽ നമ്മൾ സ്റ്റെപ്പ് ഫംഗ്ഷൻ ഉപയോഗിച്ചാണ് ആ വേർഷൻ നമ്മൾ കണ്ടു റീമാൻ ഇൻ്റഗ്രലിൻ്റെ. സോ therefore this will be less than or equal to supreme over phi less than or equal to f integral a to b phi of x dx. So this supremum will contain every step function also. So phi can also be a step function. So therefore the lower Riemann integral will be less than or equal to supreme of phi less than or equal to f integral a to b phi of x dx. And same way for the upper Riemann integral, that will be greater than or equal to, so this will contain all the step functions. Okay, so the upper Riemann integral will be greater than or equal to infirm over xi less than or greater than or equal to f integral a to b xi of x dx. And supremum, this supremum will be always less than or equal to infimum, because here you have phi less than or equal to f and xi greater than or equal to f. So therefore supremum will be less than or equal to the infimum value. ഇനി നമുക്ക് തന്നിരിക്കുന്ന ഫംഗ്ഷൻ റീമാൻ ഇൻ്റഗ്രബിൾ ആണ്. ഫംഗ്ഷൻ റീമാൻ ഇൻ്റഗ്രബിൾ ആണെങ്കിൽ the lower Riemann integral will be equal to the upper Riemann integral. So this two are going to be equal. So if these two are equal, then these values also must be equal. So if f is Riemann integrable, the inequality will become so all will become equal. So therefore supremum integral a to b phi dx will be equal to infimum integral psi dx. So that is a condition for a function to be measurable. So therefore this will be equal to upper supremum and infimum. This will be equal to the Lebesgue integral integral a to b f of x dx. So that will be now equal to the Riemann integral. So we will get the required result. So Riemann integral from integral a to b f of x dx, that will be equal to integral a to b fx dx. Now let us look at the next proposition. So the next proposition states that so if f and g are bounded measurable functions defined on a set E of finite measure, then integral over E af plus bg, that will be equal to a integral over ef plus b times integral over e g. And if f is equal to g almost everywhere, then the integral values of f and g will be equal. And if f is less than or equal to g almost everywhere, the same will hold for integrals also. And modulus of integral f will be less than or equal to integral of mod f. And if we have a less than or equal to f less than or equal to b, then a into measure of e will be less than or equal to integral f that will be less than or equal to b into measure of e. And if a and b are disjoint measurable sets, then integral a union b f will be equal to integral a f plus integral b f. So now we will look at the proof for the first part. So we will show that integral over e af plus bg is equal to a integral f plus b integral g. So in the proof we will be first showing that integral over e af will be equal to a times integral over f, and then we will show that integral over e f plus g will be equal to integral f plus integral g. So combining both we will get this result. So let us look at the proof. Now okay, so we are going to prove that integral over e. So this is the proof for the first one. Af plus bg, that will be equal to a integral over e f plus b integral over e g. Now let us start with a simple function. So if you have a simple function, then the constant multiple of that will be again simple function. It means it will assume finite values and it will be measurable. So function simple ആണെങ്കിൽ അതിന്റെ constant multiple simple ആയിരിക്കും. So let us prove this result. Now let us consider the three cases. So a is a constant, so a can be greater than 0, a can be equal to 0, a can be less than 0. So we'll show that in all the three cases integral over e af will be equal to a times integral over e f. Look at the case when a is greater than 0. So we need to show that integral over e af is equal to a times integral over e f. So by definition, integral over e af will be supremum over 5 less than or equal to നമ്മുടെ function af ആണ് f എന്ന് പകരം, so that will be supremum over 5 less than or equal to af integral over e 5. Now 5 less than or equal to af can be written as 5 by a less than or equal to f. So that will be supremum over 5 by a less than or equal to f integral over e 5. ഇനി 5 സിമ്പിൾ ആയതുകൊണ്ട് 5 by a simple ആയിരിക്കും. So a is greater than 0, a is not equal to 0, 5 by a is well defined. So 5 by a will be simple. And now let us replace 5 by a by 5 dash. So put 5 by a equal to 5 dash. So this will become supremum over 5 dash less than or equal to f integral over e. Now 5 will become, this will be equal to a times 5 dash. So we will get a 5 dash. And now 5 dash is a simple function. ഇപ്പോൾ ഇവിടെ 5 പ്ലേസിൽ a 5 dash വരും. 5 dash simple function ആയതുകൊണ്ട്, so in the case of simple function, integral a 5 dash will be equal to a integral over e 5 dash. So that is true in the case of simple function. So we will get supremum over 5 dash less than or equal to f a integral over e 5 dash. So that will be a times supremum over 5 dash less than or equal to f integral over e 5 dash. And now this is in the form of the integral e integral over e f. So integral over e f എന്ന് പറയുന്നത് that will be supremum over 5 less than or equal to f integral over e 5. So it is in that form. So in place of 5 we have 5 dash. So that is again remains the same. So that is A integral over E f. So we have shown that integral over E AF is equal to A times integral over E f. Now this is the case when A is positive. Now we will look at what happens when A is 0 and A is negative. A is equal to 0. A equal to 0 ആകുമ്പം AF is equal to 0. So integral over E AF will be, so that will be equal to 0. So that will be same as 0 times, so 0 into integral over E F, that will be also equal to 0. So A 0 ആകുമ്പം, so if you evaluate integral over E AF, that will be 0, and A times integral over E F will be 0. So both are equal in this case. So therefore when A is 0, again we have proved the result. Now we'll look at the case when A is less than 0. So again when A is less than 0, by definition integral over E AF will be supreme over 5 less than or equal to AF integral over E 5 varum. Okay, and now here A is less than 0. So when you take 5 by A, 5 by we have 5 less than or equal to A, A negative either. So you divide by A on both sides, inequality will reverse. So you will get 5 by A greater than or equal to F integral over E 5. And now let me put xi equal to 5 by A. So again 5 will be equal to A psi. So psi equal to 5 by A കൊടുക്കുക. അപ്പോൾ 5ന്റെ വാല്യൂ A psi ആവും. അതിവിടെ നമ്മൾ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യും. ഇവിടെ 5യുടെ പ്ലേസിൽ A psi സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക. And this can be replaced by xi. So the integral over E AF reduces to, so we will get supreme over xi greater than or equal to F integral over E A psi. And now this is integral over E A psi. Xi simple function ആണ്. Simple function ന്റെ കേസിൽ so integral over E A psi will be equal to A integral over E xi. So this will be supreme over xi greater than or equal to F. Okay. Now this is a ഇവിടെ A എന്ന് പറയുന്നത് negative value ആണ്. So we'll see what happens when you take A outside. So if you have a set of this form -1 -2 -3, so that can be written as -1 times the set 1 2 3. So the supreme this set is -1. So when you take -1 outside E set in there. So this is your set. ഇതാണ് നമ്മുടെ A psi എന്ന് പറയുന്ന സെറ്റ്. ഇതാണെങ്കിൽ ഇതാണ് -A times psi. So the supreme of this will be -1. Now if you take -1 outside, then the supreme is -1 times the infimum of this set. Okay, അപ്പോൾ -1 വെളിയിൽ എടുക്കുമ്പോൾ നമുക്ക് supreme ആണ് കണ്ടുപിടിക്കേണ്ടത്. അങ്ങനെയാണെങ്കിൽ supreme will be -1 into infimum of ഈ സെറ്റിന്റെ infimum ആയിരിക്കും 1. So -1 into 1 ആയിരിക്കും വരുന്നത്. So here when you take A outside, so supreme was I greater than or equal to F. A integral over E xi will be equal to A വെളിയിലേക്ക് വരുമ്പോൾ, so for the remaining set you need to take the infimum. So that will be equal to A infimum over xi greater than or equal to F integral over E xi. And now this, by the definition of integral of F, this will be integral over E F. So we will get A integral over E F varum. So therefore again when A is less than 0, we have shown that integral over E AF will be equal to A times integral over E F. So therefore we have got this result. So call it as equation 1. So integral over E AF will be equal to A integral over E F. And now we will show that integral over E F plus G is equal to integral over E f plus integral over E g. For proving this, so let us start with two simple functions again. So consider the simple functions phi1 and phi2 such that, so we have phi1 less than or equal to f and phi2 less than or equal to g. So therefore, phi1 plus phi2 and the simple function the summa again simple function ആയിരിക്കും and phi1 plus phi2 will be less than or equal to f plus g. So by definition of integral over f plus g, so we'll start with integral over f plus g, that will be equal to supreme over phi less than or equal to f plus g integral over e phi. And now this will be, so we need to find the supreme over all phi such that phi is less than or equal to f plus g. Now phi1 plus phi2 is one such phi. So here supreme is taken over all phi such that phi is less than f plus g. അപ്പോൾ നമ്മുടെ phi1 plus phi2 എന്ന് പറയുന്നത് that is a function such that phi1 plus phi2 is less than f plus g. So therefore ഇതെന്ന് പറയുന്നത് supreme ആണ്. Supremum will be greater than integral over e phi1 plus phi2. So when phi takes the value phi1 plus phi2, so supremum integral over e phi will be greater than or equal to integral over e phi1 plus phi2. ഇനി simple function ആയതുകൊണ്ട് നമുക്ക് simple function property satisfy ചെയ്യും. So integral over e phi1 plus phi2 will be equal to integral over e phi1 plus integral over e phi2. So therefore we have got that integral over e f plus g is greater than integral over e phi1 plus integral over e phi2. It's true for all phi1 and phi2. So it will be true for supremum phi1 and phi2. So integral over e f plus g will be greater than or equal to supreme over phi1 less than or equal to f integral over e phi1 plus supreme over phi2 less than or equal to g integral over e phi2. Now this first integral will be integral over e f1 plus integral over e f plus integral over e g. So we have got integral over e f plus g greater than or equal to integral over e f plus integral over e g. So we'll call this as equation 2. Now we will show the other way also. Integral over e f plus g is less than or equal to the sum. So in that way we can conclude that integral over e f plus g is equal to this sum. So for showing that integral over f plus g less than or equal to integral f plus integral g, so we'll start with functions xi1 and xi2 such that xi1 greater than or equal to f and xi2 greater than or equal to g. For xi1 plus xi2 again simple function and that will be greater than or equal to f plus g. So we will now do for the infimum. So by definition integral over e f plus g will be infimum over all xi greater than or equal to f plus g integral over e xi. Now this is true for any arbitrary xi. Now this will be less than or equal to any xi such that xi is greater than or equal to f plus g. Xi1 plus xi2 is greater than or equal to f plus g. So therefore this is the infimum value of infimum will be less than or equal to integral over e xi1 plus xi2. Means xi1 and xi2 is simple ആയതുകൊണ്ട് you can write it as sum of integral xi1 plus integral xi2. Now this will hold for all xi1 and xi2 such that xi1 greater than or equal to f and xi2 greater than or equal to g. So therefore it will hold for infimum also. So the inequality will hold when you take infimum over xi1 greater than or equal to f and infimum over xi2 greater than or equal to g. So integral over f plus g will be less than or equal to the infimum of these two. So that will be, since f and g are measurable, this will be equal to integral f and this is integral g. So we have got integral over e f plus g less than or equal to integral over e f plus integral over e g. So combining equations 2 and 3, we obtain integral f plus g is equal to integral f plus integral g. Now we already got that integral f is equal to a integral f. So combining these two equations, so we will get integral af plus bg, that will be integral af plus integral bg. So that is a times integral f plus b times integral g. So that completes the proof of the first